Welcome everybody to the Fall 2024 Responsible AI for Ukraine or RAI for Ukraine project showcase. I'm going to share my screen and I will run the slides and everybody can then tell me when to advance to the next slide. Okay. I hope that you're able to see the slides, yes? Okay, great.
Yes.
So once again, welcome everybody. It's great to see so many of you in the room. To start, I will introduce myself and then give a brief overview of the program. I'm Julia Stojanovic, and I have been running this program together with Tanya Zakharchenko, who will speak in just a couple of minutes, since 2022. I am on the faculty at New York University. I'm an associate professor of computer science and engineering and of data science, and I also direct the Center for Responsible AI. And RAI for Ukraine is one of our flagship programs at the Center for Responsible AI. This is the center's website. Please take a look at all the wonderful things that we do. But in particular for today, I wanted to just remind us very briefly about what the goals are of this program. And they have been stated by us when we started the program, and I think that they still remain very relevant. The goals are to provide a sense of normalcy and high-quality research opportunities to students like yourselves in Ukraine who are going through this very difficult time. Also to provide mentorship opportunities to graduate students and postdoctoral researchers from other institutions. And finally, in the long run, to help build research capacity in Ukraine in STEM, science, technology, engineering, and mathematics, in artificial intelligence, and specifically in this very important field of responsible AI or RAI. The structure of the program is that we start with an open house where we invite folks who have applied to participate to get a sense of what the projects are going to be for that particular academic year. The open house is at the start of the fall semester. And then during the fall, like we did last year, we work on projects collaboratively with international mentors and receive academic credit for the work. And the culmination of this first semester is a project showcase. Then for those of you who are enjoying your work and in case that the mentors also think that the project is promising, we are going to look at your project reports, we'll discuss with the mentors, and we'll then offer to some of you paid research internships for the spring semester. And sometimes these continue into the summer. And then we will also do a showcase at the end of the spring and at the end of the summer. We have a website for the program. Please take a look at r-ai.co/Ukraine. Just some very brief statistics are that we launched in June 2022. So far, we have engaged 72 students from 11 Ukrainian universities in research. And this research has been supervised by 47 mentors from 23 academic institutions in 8 countries in the US and Western Europe. And we hope, of course, to grow this cohort in years to come. Yaroslav is not going to be with us today, but he has been our partner in establishing this program. So maybe Tanya, you can speak and also say a few words about Yaroslav's involvement and then your own. So this is your slide.
Hello to everyone. I guess Yaroslav and as well as with me, want to thank you, Julia, and all the mentors for your time and support during all these years, especially for giving the students who can't leave the country opportunity to collaborate internationally. Of course, I would like to thank all the students for your dedication during this semester, and especially for students who are with us from 2022. I'm sure it was like great time of research, and I really like anticipating our presentations today.
Okay, great. So I also forgot to mention, but I should, that we make comic books, and this year we finally released the Ukrainian language version of the comic book series We Are AI, Taking Control of Technology. And if you'd like a hard copy, we can, let Tanya know and we can try to get you one. And you can also download these comics in PDF from the responsible RAI for Ukraine website. Okay.
I still have some, like
Yeah.
maybe approximately 10, like printed.
Yeah, and then we can also reprint.
Yeah.
Yeah, so as far as the structure of this time that we have together today, we have 3 continuing and 14 new projects. So that's 17 projects in total that are going to be presented. This means that we really all need to stay on time, right? So at most, the project presentation for each project together with the brief Q&A is 7 minutes. So please do your very best to wrap up your actual presentation within 6 minutes. If you want to leave time for a question, I would really advise you to wrap up within 6 minutes. And I will keep track of time. So please just tell me when to, or maybe Tanya, you can keep track of time to help me, yeah? And then please just, Tanya, speak up to say time is up. Yeah.
After 6 minutes or 7?
You can put it into chat, right? After 7 minutes, time is really up.
Yeah, okay.
Okay, so let's do this. We start with continuing projects. And the first one is Virni Flow, and I'm going to hand over to Denise and Nazar.
Yeah. So thank you. Hello, everyone. My name is Denis, and together with Nazar, we are glad to present our project supervised by Julia, which is called Virni Flow, Design Space for Responsible Model Development. This project builds on the foundation of our previous projects in this research program. And of course, we are deeply grateful to Julia for her invaluable support and guidance. So the motivation for this project stems from the multi-objective nature of most real-world ML tasks. For example, in hiring, fairness is just as critical as accuracy. Similarly, other tasks, such as those in healthcare, prioritize stability as a key objective within the ML pipeline to ensure reliable and safe outcomes. The second motivation is that some objectives, such as fairness, cannot be automated, which has been discussed in multiple academic papers over the last several years. A human domain expert should be involved in defining what is good model performance, depending on the context of use. The third motivation is that model development spans various stages, which require extensive experimentation to reach the desired objectives. Therefore, responsible model development is an iterative process that takes a lot of time and resources. And finally, yet ironically, most optimal systems fail to achieve all of this. Next slide. This motivation leads us to the goals of Virni Flow, which we also refer to as the design space. The first goal of our design space is to offer flexibility in defining objective criteria tailored to the specific context of use. The second goal is to tune ML pipelines by addressing multiple pipeline stages, performance objectives, and constraints. The third goal is to streamline extensive experimentation, optimizing ML pipeline execution, and providing a comprehensive experiment management platform. And the final goal is to incorporate a human-centric design that emphasizes interactivity and trustworthiness, empowering users to rapidly iterate and enhance their ML pipelines. Next slide. Yeah, so we recognize that the goals of Virni Flow are highly ambitious and difficult to achieve without building on prior work. Therefore, Virni Flow leverages 3 existing frameworks, each presented at top-tier conferences. The first framework, which is called Virni, enables the measurement of all normatively important dimensions of model performance, both overall and broken down by user-defined groups. The second toolset, which is called OpenBox, offers a range of optimization techniques through a standardized API, supporting single objective and multi-objective tasks with or without constraints. The third system, which is called Alpine Meadow, provides efficient selection and pruning strategies to ML pipeline development by combining cost-based multi-arm bandits with Bayesian optimization. Next slide. VirniFlow integrates these three frameworks into unified system architecture, making a significant step forward in advancing responsible data management systems. Considering time constraints, I will provide a high-level overview of the diagram. The process begins with the user providing an experiment configuration, including all pipeline components, objective criteria, and optimization strategies. Next, the task manager initializes all dependencies and generates tasks, where each task represents a physical pipeline, which is a specific configuration of the ML pipeline with defined components and hyperparameters. Next, the tasks are added to a new tasks queue and executed by workers. When completed, the metrics associated with these pipelines are sent through the completed tasks queue to cost model updater to update all cost models in the system. The system continues this process until the specific number of optimization trials for each logical pipeline is reached. All metrics for each trial are stored in a database and can be interactively reviewed by the user. Next, Nazar will present more detailed features of the system.
Yeah, our system has a fixed pipeline structure, but each component is built using modular design. It is designed to be fully customizable and extendable, which allows user to extend existing components or add new via interface. And we provide 6 imputation methods to handle missing data effectively. They covers different types of imputers like statistical, machine learning, or learning-based. Also, system has 6 fairness interventions, which covers all possible types like pre-processing, in-processing, and post-processing. And finally, 6 ML models from simple logistic regression to Gandalf deep learning architecture for tabular data. Next slide, please. For optimization part, we used OpenBox and implemented 4 techniques: single objective black box optimization, single objective with constraints, multi-objective black box optimization, and multi-objective with constraints. Optimization covers all components, so each step, like null imputer, fairness intervention, or model, has their own config space, which is be optimized for our objective. Next slide, please. For visualization, we used OpenBox UI, which allows us to analyze optimization results like objective chains through iterations, Pareto, front, and other. And from these plots, we can analyze that optimizer takes into account 2 objectives and minimizes them both simultaneously. Next slide, please. And in the experiments with different objective weights for accuracy and fairness, we used custom plots for F1 score and equalized odds TPR. And the last one, please. For the future, we plan to send a revision of Shades of Null to VLDB25 track of experiments and analysis, complete experiments for VirniFlow, and also finalize the VirniFlow draft and submit it to VLDB25.
Thank you very much, and right on time.
Yeah, thank you for attention.
Yes. So this has been
Optimized.
an ongoing project, and yeah, we're very happy that we got a positive response from VLDB on the submission. So we'll see how that goes. Questions? If there are no questions, let's move to the next project. And that project is on explaining rankings and preferences, and I will hand over to Ivan. I believe Katya
Yeah.
can make it today.
Yeah. Hi everyone, I am Ivan, and together with my teammate Katya, who unfortunately cannot join us today, I'm working on a project Sharp explaining the ranking and preferences under the mentorship of Venetia, Joao, and Julia. Next slide, please. So first of all, rankings. They're used to daily important decisions such as college admission, hiring, lending, etc. These decisions rely on ranking systems that range from relatively simple score-based to more complex learning to rank models. The problems with all of these methods is that rankings are often difficult to explain, even for straightforward scoring functions. For example, on the slide, you can see the dataset of college applications that was scored using 2 different equated sums. The resulting rankings are very similar, showing that even a highly explainable scoring function cannot help us explain the ranking it produces. This happens because scoring evaluates each item independently, while ranks outcomes are interdependent. Next slide, please. To address this issue, several methods have been recently developed to provide explanation specifically for rankings. One such method, Sharp, defines specific quantities of interest for explaining outcome, including both score and rank. Plots on the right show that the explanation for some data point can vary significantly depending on the chosen QI. Even so, the rank in our case was directly computed from the score. Next slide, please. In this project, we aim to build a benchmark to experimentally compare these methods, as there are currently no established baselines or frameworks for such comparison. This is, however, not an easy task to do, as these methods differ in their approaches. To start, we define comparison dimensions, some of which are shown on the slide. They can be used afterwards to help determine which methods are best suited for explaining specific ranking model. Next slide, please. In previous semesters, we discovered some methods for explaining rankings and integrated them into our framework to have a common interface for working with them. Afterwards, we ran them on the datasets, one of which we also created, to ensure the correctness of our code and also integration. Next slide, please. Starting from the previous semester, we focused on comparing the result of these methods. The goal was to create a way to do this. The main challenge here is the lack of standard units for measuring feature contribution, which makes direct comparison of raw values impossible. For that, we introduced 3 different metrics that quantify some of the properties of this method, namely fidelity, agreement, and sensitivity. We begin with fidelity, which measures how well an explanation method allows the outcome, in our case the rank, to be reconstructed from the explanation. We quantify fidelity by measuring the distance between the outcome and the sum of all the feature contributions. On the right, you can see the fidelity scores for each method that has this property, averaged across all the points in the datasets. Next slide, please. When comparing methods, it would be also great to know if 2 methods would give similar explanation for similar data points, or so to say, agree with each other. In this context, it is very important to define what each similar actually means. For this project, we used 3 ways to measure the similarity of explanations. The first one is Kendall-Stau, the second is Jaccard distance for 2 most important features, and the last one is the Klein distance. The data points are considered to be similar if they have similar outcome, so rank in our case, similar feature vectors, or both. Next slide. From this broad definition, we can actually derive 2 metrics. The first is agreement between methods, quantifies the similarity of explanation from different methods for the same point, averaged across all of them. On the slide, you can see the result averaged across all datasets for each pair of methods. And the second one on the next slide is the sensitivity, which assesses how consistent a single method's explanations are for 2 similar data points. The result for the CS ranking dataset and some of the methods you can see on the plots, where the x-axis represents the Euclidean distance between explanation vectors, y-axis the distance between the ranks, and color the distance between the feature vectors. And currently, we are working on finalizing the Sharp paper for peer review and cleaning up and documenting the code base for our comparison framework. We are also look forward to working on a paper presenting our comparison findings. Thank you all for your attention. Maybe you have some questions.
Once again, great job. stayed right on time. Very clear.
Yeah, I have a question. How do you measure agreement across data
So
points?
agreement, we measure a similarity of two explanation vectors, and similarity is one of these distances I described.
Mhm.
Yes, if you look
Okay.
at these things here, right? I mean, there are some weights that are assigned to each feature. You can sort these features by weight, by the absolute value of the weight, for example. And that
Mhm.
tells you
But
how important the feature is. So that gives you a little ranked list of features. And then you can
Yeah.
compare these ranked lists.
But you create this feature importance for each data point, and after that compare this feature importance between different data points of the same data set. My idea was what will be if we'll take the same data point, slightly change feature, and look what will be the output of the ranking algorithm. Will it change or not? It's the
Yeah.
same as
This is
Bootstrap
also
works.
this is also can be viable way to compare, but we focused on comparing like two methods. What two methods actually what explanation do different methods give for the same point, and comparing this.
But
Yeah,
then
but you
what
also
we're
can.
talking about, Denise, is essentially how feature importance really is computed using Shapley values. As you intervene on features and you see what happens, whether the outcome changes. We can discuss this certainly.
Yeah.
It's
If
interesting.
I can just chime in quickly, just so Denise, what you were describing is something that would be very useful to measure something like, for example, the stability of the rank, right? So like if you insert perturbations, like how likely is it to change the rank? In this
Mhm.
case, we're trying to understand, like, for a given explanation, how similar is it to another method that also produces explanations? See, so like one of the ways, for example, is so like understanding like or an ordered list of importances, or like from the most important to the least important. How similar are they? So in this order, for example.
Okay. And another my suggestion was to look at how people compare different techniques to measure uncertainty quantification, because uncertainty quantification also have different techniques. People compare them. Also, there are no ground truths in explainability. But in uncertainty quantification, it's even harder, because in explainability, we can logically understand if this feature really should correlate with the outcome. In uncertainty, you really cannot even, from logical perspective, know this. So from that field, you also can look what methods do they use to compare different techniques. I know some of them, but it will take some time to explain everything here. So
This is also a great idea, and we've done some work. I've done some work before on stability in ranking. And so this, in fact, is related. But in general, ranking is a field that relatively few people look at, and where the concerns are quite distinct from classification, right? So if any of you are interested in thinking about this work, let's definitely discuss offline. Bogdan, I think you have a question as well.
I have a small question about SHAP method. Isn't it like, can you return to fidelity metric, please? Yeah, isn't like the axiom of SHAP that it should be equal to the prediction, like sum of Shapley values should equal always to the prediction, and actually the method like should work like this.
Yeah,
I'm interested why it's not equal to the one in datasets.
I can respond if unless Ivan or Joao.
Yeah, but if we calculate the exact value of Shapley values, it requires a lot of running time. So often the approximation is used. So
Yes.
not all subsets are considered.
Yeah,
Thank you.
and then the other point here on about the Hill method, I don't know, Ivan, if you can explain this. If not, I'm happy to. So why is fidelity of Hill so low? It's not just the approximation conversation, it's that it doesn't actually compute Shapley values.
Yeah.
So they have some alternative that they give, but if you believe that fidelity is important, this essentially says that the method is not great. Right?
Thank you.
Exactly.
Yeah. But yeah, great questions. I'm glad there's so much interest. It means we're doing relevant work. Yeah. Okay. So let's move to the next project.
Thank you very much.
Yes, thank you. And this project is Creedle. Matvey and Olha are here, I believe. Yes.
Hi everyone, thanks you for joining us today. My name is Olga and Matvey is my teammate. We are both first-year computer science students from Ukrainian Catholic University. Also, we've had an invaluable support of two incredible mentors, George and Julia, who have played a significant role in enhancing our project. During this semester, we focused on validating and testing the methodology we previously created, so let's recap the project objectives we set. In case you never heard about close reading, it is originally a method used in literature to analyze small pieces of text or poems, but we adapted it for data modeling tasks. So Quidel is methodology for giving users the experience and tools they need to actively participate in building data models, making models more comprehensible and fair by identifying the mitigating biases, and providing users with valuable skills and tools for analyzing data models encountered in their work. Next slide, please. Last time we completed the Quidel methodology, which was revised after the pilot workshop we made, and then we developed a set of interview questions along with supplemental materials, including example of reading and a video tutorial. Next slide, please. In the current phase, we focus on testing and validating the Quidel methodology. One of the ways to achieve this was by involving others and asking them to test it, which is exactly what we did. Based on the methodology, we created a tutorial along with all supplementary materials needed to help users follow the methodology and achieve meaningful results. Next slide, please. Regarding the test audience, we decided to collect feedbacks by conducting qualitative interviews. In total, we interviewed 11 students, 4 data science master degree students, and 7 computer science bachelor degree students. Before the interviews, we shared the tutorial with all participants and waited for them to notify us when they were ready. This approach is better than online workshops because close reading involves careful and detailed analysis, making it essential not to create any time limits for reading process. All participants who take part in the Quidel testing had at least basic experience with data modeling, enabling them to complete the methodology and work with data models effectively. However, none of the participants were familiar with the literature close reading method, and to explore this dependency further, about the audience of the interviewees needed. Next slide, please.
Yeah, so I hope you can hear me well. To analyze the feedback collected from the participants, we adopted a systematic approach to ensure reliability and anonymity. All interview recordings were transcribed to anonymize the data and protecting the identity of participants while preserving the depth and richness of the responses. So the analysis process, in the analysis process, we use Atlas T tool to efficiently code and categorize participant feedback. And all 4 participants of the projects came up with their own code book, and each team member independently coded the transcript, and these individual codes were collaboratively reviewed and merged into one unified code book. And this final code book actually categorizes the data into 4 topics. The first one would be the participant background, which is capturing the participants' experience level and perspectives. The second one would be the methodology strengths, which highlights the aspects of Quidel that were particularly effective and beneficial. And then we go for the methodology effectiveness, which assess the extent to which the methodology met its intended goals of usability and applicability. And then we go for the methodology improvement, which documents suggestions for refinement and future enhancements. And this actually ensured the comprehensive and quite nuanced understanding of the participant feedback. Next slide, please. Here we just summarized the key insights from the interviews we conducted to evaluate Quidel methodology. So here we can see that the most frequent possible feedback was about positive feedback was about supplemental materials, which was mentioned 28 times. Participants found the guides and examples very helpful in understanding the applying the methodology. Another highlight is the methodology's potential for future use, which was mentioned 18 times. Many participants expressed interest in applying it in their work or studies, which actually reflects its practical value, I'd say. And yeah, the structured approach of Creedle was praised like 13 times, with participants like appreciating the step-by-step process for navigating data models. And additionally, participants noted improvements in the data modeling skill, which was like 12 mentions of increased proficiency in understanding and handling data model. On the other hand, we identified some areas for refinement. For instance, improving bias representation was mentioned 8 times. Participants suggested that clear explanation and examples are needed to better guide them in identifying and addressing this bias. And another 8 mentions were about improving the supplemental materials further. The suggestions included like adding more diagrams, visual aids, diverse examples to enhance clarity and accessibility. So the bar chart below visualizes this distribution of feedback across all categories. As you can see, the strengths of the methodology, such as helpful materials and the structured approach, stand out. And at the same time, the improvement areas like bias presentation, supplemental materials provide like valuable directions for us to enhance the methodology. Next slide, please. Okay, I'm just going to briefly mention here that we have the paper structure, which we actually are excited to share. That the paper detail of our work on the Creedle methodology has been submitted to CSCW 2025, and it's currently under review. Yeah, then we'll go to the next slide so that we can finish. Here we just outlined the future upgrades for improvements that we envisioned for the Creedle. First, we are exploring methodology automation, which many participants suggested. Second, we want to improve the supplemental materials, which still remains a priority for us. Third, we are considering case-by-case customization. This will involve like creating 2 different versions of the methodology, one for more detailed in-depth analysis, second for quick evaluations. And next, we see an opportunity to increase domain expert engagement. And finally, we are planning to do semi-structured interviews with the students at Technology University of Eindhoven, scheduled for mid-January 2025. So yeah, overall, these upgrades aim to enhance usability and scalability of the effectiveness of our Creedle methodology. So we are happy to answer your questions.
Thank you very much. We are actually a little bit over time, so maybe one quick question.
I have one quick question.
Yeah.
Are there any other techniques to compare with your one? So do you compare it somehow with others? I think there are some other techniques also that can help to build this entity relational models.
Well, the methodology itself is more about analyzing the data models, not about building them, but about the similar approaches when creating this methodology. This was actually, well, as far as we know, it was the first ever methodology that would address this kind of issue. So while there remain some different approaches that would address some specific issues that we mentioned in the methodology, like the exact one or the one that would address overall the same picture, I wouldn't say that there are the same tools
Okay.
Okay, let's
at the moment.
next presentation. Thank you again. So now we are switching to the projects that were started this semester. And the first one is going to be on a topic that is kind of follows on the Creedle project. And for this, Victoria, Anastasia, and Roman will speak.
Thank you. So, hello everyone, my name is Victoria, and together with Anastasia and Roman, we are going to present the PADERM project, which stands for Participatory Design for Entity Relationship Models. Next slide. So, during the first weeks of the program, we have explored recent researches related to participatory design. One of the main themes, this research is well defined by the name of the work by Sasha Konstantichuk, Nothing About Us Without Us. They bring up shifting direction from fixing people to creating accommodating environments. Next slide. In the work, participation is not a design fix. 3 key types of participations are identified: participation as work, as consultation, and as justice. Each type presents unique challenges, largely due to lack of clear standards. For instance, individuals may unknowingly contribute to data collection.
This form of hidden participation often means that their labor remains unrecognized and unpaid. So creating an explorative dynamic, exploitative dynamic where participants are uncertain of their role and the goals of the participation. Existing participatory methods also face limitations, particularly in areas like ER modeling, which remain underexplored. Next one. So we have designed the model that represents a structured approach to incorporating participatory design into ER modeling. It moves from broad, general ideas to a well-defined and strict ER model. The Onion framework consists of the next stages. Begin by observing the world to understand real-life system and context. Then facilitate and nurture participant ideas, encourage collaboration. Incorporate participant contribution directly into your model. This step bridges general concepts with formal system design. Then we have to refine the model based on participant feedbacks. And finally, we align the model with restrictions and technical requirements. The next one. This participatory approach ensures the model is inclusive, reflects real-world complexity, and meets both participant and technical needs. It enables the shift from general ideas to strict ER models through continuous observation, collaboration, and refinement. So we highlight key principles. Each layer builds on the previous one. We can revisit earlier stages, fostering flexibility. Broad concepts are shaped and refined into robust strict systems that align with technical and real-world requirements. Now Anastasia will explain how we have applied the model in practice.
So we tested the Onion methodology in the case study Student Council communication system. Our initial goal was to create an ER model for a platform which would connect Student Council and students. In the first stage, we defined that for our goal, we need to ask about students' experience with Student Council. And naturally, our participants had to be members and non-members of Student Council. Then we conducted an open question survey using the Google Forms. In the end of the form, we asked whether the participant wants to continue their participation in the project in the next stages. So 7 people filled the form and 4 of them agreed to take part in the next stages. Next slide, please. According to participants' answers, we refined our goals so that to create ER model for the platform which would improve communication between students and Student Council. To fully engage the participants, we decided to hold 2 meetings in Zoom where non-members and members of Student Council could talk about how they see the platform and construct a simple schema of it without us as facilitators. Next slide, please. And after these meetings, we combined 2 schemas that participants had created into the ER model. Next slide, please. In the optimized stage, we had 2 meetings with participants one-on-one, where we explained to the participant the created ER model and asked if it represented their ideas correctly and what we needed to change. One of the participants didn't have objections to the ER model. The other participant suggested a few changes. After the internal validation, we refined the ER model and moved to the technical validation. Next slide, please. To perform this step, we have requested an external professional review of the final ER model in order to gain technical feedback. As a result, our model didn't require conceptual changes, but more technical ones, which means that we didn't have to go back to the phase with participants and can only improve technical implementation. Next slide.
So, in conclusion, the Onion methodology has shown to be effective. It helps bring stakeholders together to create solutions while reducing biases. As was shown in our Student Council case study, it's improved communication between ordinary students and council members, helped identify areas where understanding between them was lacking. The process ensures that stakeholders' input shapes the final design and the technical goals align with the end users' needs. Overall, Onion has the potential to work well in small systems and could be adapted to broader use if the idea is developed further. Next slide, please. And for the next steps, some future efforts to improve the methodology could focus on several key aspects. Firstly, refining the framework. So by creating a simple visual vocabulary to make it easier for participants to engage in the process. And secondly, expanding research to include more diverse participants and test it on in more complex system to improve and evaluate it better. Additionally, establishing more clear metrics to evaluate how well the methodology meets both technical and stakeholders' goals to strengthen its reliability and broader applicability. In next slide, please. Thank you for your attention.
Thank you very much. We have time maybe for one question. An excellent presentation once again.
I have one question. Are there any requirements for selecting participants for your framework, or like they should have some knowledge also, or do you try to take participants from different domains? Like you have student council example, but in student council there are also different positions, some related to finance, some related to communication, and so on. Just interesting. Are there any criteria for participants?
That's exactly correct question, aligns with our research. So we also paid attention to who is going to participate. It is very important. That's why we selected people who are students, who are representatives of student council. Our research was quite small, so we didn't have the area to extend, like with different roles in student council. But this is important because in this research, we also find that not only the current role important, but also your background is important. It's important who are you? Are you a business analyst, a developer, or just maybe a psychologist or someone else? So it depends on different levels of your previous knowledge, etc. So it should be carefully designed on the stage where participants are selected.
Okay, thanks.
Thank you very much. Moving on to the next project. Okay, the next project is Maria, guiding teachers in question answer generation with AI planning.
Thank you, Julia. Hello, everyone. My name is Lech. I'm a research fellow in the Maria project, and along with Vyacheslav Odlevsky and under the mentorship of Sihem and Noah, we've been working on the project for the last 3 months. Now we are proud to present you our results. Next slide, please. Multiple choice questions are very popular for student evaluation and can be used at almost every level of Bloom's taxonomy. Every student has gone through many of them during the studies. However, high quality MCQs take a lot of time and effort to create. So with the recent advancement in AI, we thought, what if we could use LLMs to aid teachers in generating those quizzes? Next question, please. Next slide. So the Maria project was started. Here, our goal is to build a system capable of generating high-quality MCQs based on the educational material. The system must be guided by teachers and be small enough to be self-hosted on teachers' laptops. To achieve it, we choose an approach of fine-tuning a small LLM, Phi 3.5 mini in our case, with the purpose of generating those MCQs. And we also decided to build an orchestrator to assemble individual MCQs into quizzes. For our data, we relied on 370 LISA sheets split into about 5,000 medical topics initially provided by UNES. Next slide, please. Now, to measure the goodness of MCQs, we selected a list of criteria and classified them as semantic and syntactic. Let us go over them quickly. Syntactic criteria are question marks. So the question of our MCQs must actually be questions and not statements. Negation and answers. No answer should start with negations. For questions, though, such a practice is okay. Rephrasing, the answer should not rephrase the question as it leads to possibility of having multiple answers to be correct and overall ambiguity in questions. Readability, the text must be written in a language appropriate for high school, college, and advanced degree students. and answer length. All the answers should be of approximately same length. As for the semantic criteria, we have correctness, so there must be just a single correct answer. Ambiguity, the destructors must be close to the correct answer, but still wrong. Relevance to the input material, the MCQs must be generated based on the data we provide and not the knowledge the LLM received during the training. And disclosure, so the questions must not inadvertently point to the correct answers. All the syntactic criteria are measured algorithmically. For the semantic, though, there are no algorithms that can capture all the nuances, and usually they are estimated using common sense. For our case, we relied on a judge LLM, GPT-4o, to give us ranks of classes depending on the criterion. Next slide, please. Now, let us briefly cover the fine-tuning pipeline we used and the challenges we faced. So all of them can be assembled into 4 groups. Data preparation, i.e. labeling, ensuring that the model focuses on the provided material, quality assessment for MCQs, that's something that was covered on the last slide, and finally quiz-related generation orchestration, and that's something we plan to work on in the future. Now I will give a word to Slava so he can cover our experimental findings.
Yeah, thank you, Oleg. So for training our models, we use 2 approaches. One is DPO, another is KITIO. Both of these methods, they are good at aligning prediction with human preferences, and also it's a pretty straightforward process to create data sets for them. For the DPO, we need to have the accepted and rejected prompts, and for KITIO, we need to have the prompt and its label. Next, please. So yeah, here are some our empirical results. For answerability, we compared the basic models. We can see that even for the Phi 3.5 does not perform as good as GPT-4 Omni does. It's still it's not crucial for us. And for ambiguity and disclosure with the criteria we trained our model on, let me quickly recall the ambiguity. It shows that the incorrect options, they must be semantically close to the correct one. And disclosure, it's a Boolean value that shows whether the question reveals the answer. And for ambiguity, we can notice that our both KITIO and DPO fine-tuned models, they perform approximately the same as GPT-4 Omni. And for disclosure, we have a leader, the DPO performed the best. Next, please. Okay, our findings. We have performed the evaluation on each of the criteria, and actually we found out that the basic models, they have achieved decent results on several criteria. They are question marks, negation in answer, rephrasing, readability, answer length, and correctness. And we also found out that the fine-tuned models, they generally performed better than their base counterparts. And to be more precise, the Phi 3.5 Mini performed better than GPT-4 Omni on disclosure. And we need to have a mix of training approaches, because we found out that KITIO is slightly performing better than DPO on ambiguity, and DPO outperformed KITIO on disclosure. Next, please. Yeah. Our contribution, we reviewed a lot of papers, approximately 20 papers. We have came up with multiple dimensions. We prepared pipelines for DPO and KITIO, and we trained them and evaluated, and we have fancy repository with our codes. And for the future work, we want to train our model on remaining quality dimensions, their answer length and relevance. We want to investigate the applicability of AI planning for quiz generation. It's actually our main goal. And we want to know if our project, Maria, is applicable to other domains. That's all. We are happy to answer your questions.
Thank you very much. A very nice presentation. Very impressive progress over such a short amount of time. Questions? Maybe one question.
I have one question. Maybe I missed that, but
Okay.
obvious question. You use LLMs to create those questions, and the question is, did you test LLMs that they can answer them, and how good they can answer them?
In the very beginning, we had just the plain text, and it was written in French. We translated it to English, and based on this plain text, we generated the MCQs. So we put to the LLM, to the big LLM, which is GPT-4.
Okay.
We put the plain text and asked,
Slava,
please generate
Slava, the question is on answerability. Did you check that the are able to answer correctly the questions, which was your first experiments that you showed? Yeah.
Correct.
So the answer is yes.
Yes, and we utilize GPT-4o to basically calculate answerability for our MCQ.
And what is the score of answerability?
Slava, could you please?
We can go back here.
Yep, so you can see that we basically had two different goals. In one, we generated the questions based on Phi3 and based on GPT-4, and in the second run, we evaluated them basically independently from process.
Okay, yeah, great. Thanks.
All right, so let's move on. The next project, Proxy. Thank you very much. The next project is Proxy, identifying potential unlawful proxies. Tanya and Nazar will discuss this.
Julia, I will start. Okay, first of all, of course, I with Nazar Izrushak, who is already PhD student at Ukrainian Catholic University, and that is outcome actually of this program, Julia. We would like to thank our mentors, Mykola Psheninsky and Hilda Beers, for the guidance in this project. And next slide. Yeah, so our research goal was to operationalize and develop techniques and tools for identifying and analyzing potentially unlawful proxies in terms of two steps. So first of all, it's proxy capacity. For people who doesn't know what it is, it's just a criterion or criteria based on some input features, which is inextricably linked to a protected characteristic. And the second one is a proxy use when we apply that criterion or criteria with the result that individual is treated less favorably. So it could be some kind of model which like requires these input features and some labels. Next slide. For this research, we used a recent data set, Gini recruitment data set that was published by actually Nazari Drushak and his master thesis advisor, Mariana Romanishin in ISL Anthology. Next slide. Just small comments that it's a large-scale open-source corpus of job descriptions and candidate profiles with more than 150,000 jobs and 230,000 candidates in English and Ukrainian. And for our research, this data set contains like inputs that we like interested in its curriculum vitae, but doesn't have any protected features and doesn't have any decision like to hire or reject this candidate for some like position. So we come up with methods to make some reasonable approximation what it can be about, like what can be this protected feature and how we can define it, and again the same for the decision. Next slide. So we decided to research this data set according to the gender. Next slide. And here we, it's unfortunately in Ukrainian, but it's important because like exactly in Ukrainian's curriculum vitae, you can find some, like even, of course, that we don't have the gender, we still have some gender marker verbs or adjectives. And here is like in Ukrainian, how we say, I'm ready. It could be я готова or готовы, depending on female or male. And the next slide. And for example, here you have, you can see a lot of artifacts that it's written like it's female, like CV from female. So we can use it as a gender proxy based on these gender marker verbs and adjectives exactly in Ukrainian text. And we created like the script, how we can get this information from CVs. Next line. And the next, okay.
Thank you. Yeah, the script is based on the semantic trees that we can defining which words is related to what, and we can like easily change it. And what we understood after we do this, we try to create it as a data set and defining based on majority of the words related to some gender to identify what is gender for each CV. And the next slide, please. And after that, we understood that let's try to tune the model to understand and classify the gender to see if they identifying this proxy and finding the similar pattern as we find it. And as you can see, they show like a great result for identifying the genders for the data sets. And the next slide, please. If we will check it is in the text, you can see that with the sharp value that it's finding the patterns which we want and finding the same patterns. And the next slide, please. It's also not always from the one words, but can be from the different one and combining it. But if we will check the next one with the females, we have one interesting pattern. It gets the pattern which we want, but they also defining the word which name characters. And the problem with this word that it's not related, it cannot be related to some gender. And for now, we don't have like a fully decision related to this, but it looks like that this is a model bias due to the unbalanced data set. That's probably for the designers and 2D and 3D designers, we have more CVs related to the female in the dataset. That's why model now thinking that when we have these characters, it's more related to some groups. And yes, the next slide, please. Yeah, it's the similar one also with words, and yes, like the main decision, but we did was that the model can define mostly these verbs and adjectives, and we can continue working with next steps. And can you first the next slide, please? Yeah, and after we define the proxy capacity, we want to find the proxy use. And for this task, as you remember, this data set don't have the predictions of hire and reject. So for the next slide, we trying to somehow created it, and we use LLM to do the decisions. We're providing the CV and the job description for each of them and asking if the model think it's suitable for this answer. Yes, the model will produce additional bias, but we can a bit update it. And the next slide, please. For now, yeah, we are on the stage of working with this one, but it is like a current results, and we are trying to improve it because it's probably with the imbalanced data set. We will try to fix and analyze it. And the next slide, please. Yeah, we're working to finalize this fine tuning to better understand and predicted it, created as we do the gender mark defining. We want to do the changer to change the gender for male and female to create like a parallel corpus that we have the same CV as written it from the male and from the female, and see if the decision model have some impact based on these words. And yeah, based on it, we want to do like a write methodology in paper. Yeah, that's all.
Very interesting work. Bohdan, you have a question.
Yeah. What do you think? Like, is this still relevant for analytic languages like English, Chinese? I don't know, without a lot of morphemes, like in Ukrainian. Maybe there are other types of proxies or something like that. Just interesting.
Yeah, this probably have another type of proxies, but for this type, as we have with marker verbs and that, no, it's not related to these languages, but we think that it's we can find like more languages related to Ukrainians that have the similar patterns, and this concept of gender marker verbs can be applicable to them.
Thank you.
Yeah.
Yes, I'm sorry if I miss it, but typically also just already surnames in Ukraine have a mark of gender. and so this is also very complex things to do. So how do you solve that?
Based on this data set, it's probably anonymized. And why I tell that it is anonymized, the platform Jenny, it's a platform which providing the data and told to do it in some anonymized form that you're not providing your names and ads. So we told that it is like some anonymized form, and we're trying to find how another we can define this gender.
Ahmad.
Thank
And
you.
then Bill also has a comment because he pasted.
Thank you. First of all, it was a great presentation. Thank you so much. So I'm just having a recommendation. When you are having a SHAP or SHAP analysis in terms of AI explanation or explainability, I would also encourage to incorporate Lime, because each of them does have some benefits. Like Lime will provide you with prototype explainability. I would encourage to add Lime as well. So it will make your work stronger. That's all. Thank you so much.
Thank you. Thank you for the comment.
All right, great. So let's move to the next presentation. Good work. And the next one is KG-LLN, aligning knowledge graphs with large language models.
Hello, everyone. Next slide, please. Me and my team are presenting the topic of knowledge graph alignment using large language models. Let's recall what knowledge graph is. It's also known as semantic network or ontology. It's a representative network of real-world entities, such as objects, events, situations, or concepts, and illustrate the relationship between them. So what is alignment is basically matching between two ontologies, and small subtasks that can help with knowledge graph alignment are global matching, which is matching between two different ontologies, and local matching, which is matching between source entity and target candidates from different ontologies. Next slide. So first of all, let's discuss a data set. First data set that we used is BioML24, a data set which key resource is for evaluation knowledge graph alignment system, focusing on ontology matching for particularly equivalence and subsumption tasks. Here we can see 5 ontology pairs. Also, additional data set that we used was an anatomy data set, which aligns mouse anatomy ontology with human ontology. This data set is useful particularly because it has it's good for testing ontology matching systems for precision, recall, and balance. Next slide, please.
Now about our morphology, what we used like LLM like Oracle to test the ground truth that we believe that provides for us the real answer, and having those responses, we like aligned our others pipeline steps. With those responses, we produced some hypotheses and tested them. We'll discuss them later in results section. Also, we use different type of prompt techniques, different structure of prompts, and use different large language models to evaluate them. We'll move in details in the next slide, please.
Yes, so about preprocessing, what we are doing, we are using the already library to load an ontology, and after that, we are projecting it onto a graph. From the graph, we are extracting for entities its labels, properties, its hierarchy, so like child and parents. What we are doing, we are using the log map to create, to give us our possible pairs, and then we're using our LLM as an oracle to decide whether is it a match or no. Next slide, please. So about our setup, we tested 4 models. So that's GPT-4o Mini, Gemini 1.5 Flash, Mistral, and Llama. Mistral and Llama were run onto the locally using the Kaggle resources, as it's the best resource we could have, but the limitations of it, we could only get 30 hours, and it was not enough to run a lot of experiments. So we moved on to some APIs which are not open source, so like GPT-4o and Gemini, and also tested on them. As evaluation metrics, we used accuracy, precision, recall, and F1 score. As the next slide, please. So we tested for LLMs our metrics, and as we can see, the APIs perform better. So every model has decent precision. The Gemini and the GPT-4 model has better recall and resulting in a way better F1 score. And local models performed way worse. The Mistral and Llama model are 8 billion parameters. Next slide, please.
And here are the results based on the question, because we can provide to the LLM not the whole context, but for example, give some one of the most important name of the entity, or for example, give them the whole hierarchy, or only provides a few childs or a few parents. And we have to test to which extent we can provide more information to get better results, and whether we can give much less information to save some resources and time for other experiments. And here are the best results that we obtained with different types of experiments and prompting. So here are, for example, the experiments only using the names of the entities, only using the main name and the children hierarchy, a few steps. Here are with parents. Also, we're making some matching with synonyms. For example, we have two entities. We take one of it, and one by one takes the synonyms and to check whether the performance is better or worse. And what we can see here is that actually only providing one name and one synonym shows a good performance results, and there are quite enough. And the only one way to get better results is provide all the names that we can extract from the graph. And the hierarchy knowledge is somehow misleading the large language model, and they're performing the worst results. For example, you can see here that providing only parents or only children gives worse results, and if we provide the full hierarchy, the results are quite much worse. To the next slide, please. And also other insights that we obtained, we use like different prompting techniques, few shots and zero shots. What we've seen is that the few shots, it's very hard to obtain the better results because it's somehow misguiding the model. Also, the initialization impact, the way we provide the general knowledge of the model and the context is important. The confidence estimation, we estimate the confidence of the model and to obtain some better precision recall results, but it's not quite good for now. Also, we are analyzing the file cases for the model to get the results. And the next slide.
For the future work, we are planning to extend the benchmarking of more models, do much deeper prompt engineering. Also, we will incorporate LLM judge to local matching, global matching, and only for some specific cases because of its expenses that can be, because there are better systems and more cheaper for that. Also, a deeper investigation of hierarchical structures. And as the result, we are planning to target the conference and workshops like International Semantic Web Conference or very large databases conference and ontology matching workshop. That's it. Thank you.
Thank you very much. Very interesting work. Tanya, do we have time for a question? Are we over time?
Just one.
Okay. Is there a question?
I have one, but I'm not sure if you will answer it. So how do you estimate confidence? You mentioned that on your slide with other insight, and for me, just interesting to hear your answer.
Yeah, we obtain the log props of the model, and we provide we ask the questions and ask her to provide the reasoning, and based on that reasoning, the model is much more or less sure if the entities are the same or no. So that's how we obtain the confidence for that.
Okay, you mean that by confidence. Okay, great. Because Tasco confidence estimation for LLMs is quite hard. So for me, it was interesting. What did you use for that? Okay.
Okay, thanks very much. We're moving to the next presentation that is on causal Shapley values for causal interpretability.
Yeah, hi everyone. I guess I've changed my photo too late, so in this version it's still photo of George, but okay. So yeah.
Go.
Yeah, thank you. So my name is Svetlana, and together with Maxim and George, we worked on the Causal Shap project, and we also would like to thank our mentors, Joshua and Sakina, for their support and guidance. And next slide. So what was like the problem we tried to solve to the goal of our project is, as you probably know, there is a method called Shapley values that is often used for attributing contributions of different features to a model, to its prediction. And basically this method fails when the features are correlated or when some causal structure is present within the data used in the model. So next slide. A bit information about Shapley values themselves. Basically, it's a concept from game theory for the case when you need to attribute contribution of different players. There's a need to define some value function for this setting, which needs to satisfy 4 axioms, which you can see on slide now. For example, like when player makes no contribution in all of the coalitions, its attribution should be equal to 0. Basically, Shapley value should be equal to 0. And one more important axiom to remember is symmetry, as it will arise more in next methods that we reviewed. So yeah, when 2 players make equal contributions, the values attributed to their impact should be equal. And here you can see the unique equation that satisfies these 4 axioms. That's basically how Shapley values are defined. So in our project, we researched and compared different methods which can actually like incorporate causal structure in data. So next slide. To test different approaches, we used we generated some synthetic data based on some causal structure, some causal relationship between features used, and these test cases we would like review more during next few slides.
Building on what Svetlana presented, I will explore Shapley values evolution, focusing on marginal and conditional Shapley values, as well as the more advanced asymmetric Shapley values. Marginal Shapley values are computed by averaging future combinations over all possible values of other features, assuming independence. This allows them to capture only the direct effects of features. However, this simplicity comes with significant drawbacks. They fail to account for realistic feature combinations and may assign attributions to scenarios that are impossible in practice. To address these limitations, conditional Shapley values were introduced. They condition on observed features values to account for independencies, making attributions more realistic. Yet they have a critical limitation. They do not differentiate between correlation and causation. Next slide, please. This is where asymmetric Shapley values come in. They incorporate causal knowledge by relaxing the symmetry axiom of traditional Shapley values. Rather than treating all features equally, they prioritize causal relationship, assigning greater attribution to causal ancestors over their descendants. This causal awareness ensures that attributions better reflect the actual pathway of influence within a model. And now Maxim will guide us through causal Shapley values. Next slide, please.
Yes, another type of Shapley values is causal Shapley values. In contrast to asymmetric Shapley values, where a causal model is incorporated on the level of permutation, inside it, a causal Shapley values, causal model is incorporated on the level of computing probabilities. And what the authors show that these 2 approaches are fundamentally different and can be perceived as 2 separate improvements. And as we can see on the graphs is right, for both of the cases it worked correctly. So for the first case, it correctly identified the positive effect of both features, and in the second case, it's correctly identified the 0 attribution for feature P. Another interesting feature of causal Shapley values is that you can easily decompose it into a direct and indirect effect, which you can see at the right. Intrinsically, if you will sum up the indirect effect of feature P, the feature f, for example, for the first case, will give exactly the value which you get using the marginal Shapley values, leading us to the better intuition of what marginal Shapley values do. And next slide, please. Yeah, the causal Shapley values can be used together with relaxed symmetry property. And on this simple example, we have one feature f, which is mediated by feature p. In this case, the explanation by causal, symmetric causal, and asymmetric causal will have a fundamental difference. In case of symmetric causal, we can see that they spread indirect impact of feature f evenly between itself and the feature it's mediated. In this case, it's p. So we have attribution of feature f only 0.25. And while the asymmetric Shapley values assign all the attribution of indirect impact of feature f to itself. Yes, all the impact of feature f goes to f. Next slide, please. Here we have a bunch of more different causal structure, a bit more complex. The key takeaway here is that we have to choose Shapley value according to the underlying causal structure. And there is no kind of unified way some of the Shapley values are worse or better. It depends on a use case and should be chosen accordingly. Next slide, please.
Yeah, we also reviewed a few more methods that are not included like in this detailed view on results. Basically, were do Shapley, which use the same attribution formula as symmetric causal Shapley, yet have no restriction on ML model availability, and also a few more contributions made by these authors, which we can discuss during Q&A session. They also were rational and counterfactual Shapley values, which actually have nothing to do with structural causal models. First method, stretches the notion of no universally good explanation and is based on this and defining relevance of spaces for different users querying the model. And counterfactuals, it is important to mention that it's not like causal counterfactuals. It's basically just another value of some feature. They allow user to understand what to change the prediction of model. And next slide would be on our next steps, which basically are about including other new SHAP proposals, for particularly PV-SHAP, finishing testing causal limitations of methods we already reviewed and are going to review in the future, a complete tutorial we prepared alongside with research in these methods, and possibly develop a new method. And then next slide would be for Q&A.
Thank you very much. A very nice presentation, very interesting work. Time for one question, because we're tight on time. Or we can go to the next presentation. Thanks again. Next, safe hierarchical classification.
Yeah. Hello, everyone. I'm happy to introduce you to our project, SafeHIC. On the slide, you can see our dear mentors, Michael Benedict from University of Oxford and Joel Zombry from a institute, me and my fellow colleagues from Ukrainian Catholic Universities, Mikhailo and Anna. Next slide, please. So what do we solve? The multi-label classification is a standard problem where an ML model should predict a set of classes, for example, 0, 1, 0, which means that some classes are present in the input and the others are not. But what we research is LCMC, which is logically constrained multi-label classification, when you have a set of classes in addition of some constraints in the form which you can see on the slide. That means that if classes A1 through AK are predicted as true, and classes AK plus 1 through AN are predicted as false, then class A should be predicted. This kind of problem arises in high-stakes domains, such as autonomous driving. For example, NML models should not predict to turn both right and left, and it should obey some rules. Additionally, it would be great if we have models that leverages constraints when we have a setup with low amount of data. Next slide, please. We started our research by reviewing the literature, and the state-of-the-art model in this domain is CCN. We have model H, which we refer to model 1 in the following slides, and also constraint model, which processes the output of model H and makes the output of the model coherent with the constraints. Like it always satisfies all the constraints. Next slide, please. Now we will introduce you to our solutions, which we came up with during the semester. And I give the word to Mikhailo. Or Anna. Anna, yes.
To me. So first we tried some simpler methods, for example, just post-processing the results of model 1 without training model. So basically what we did, we sorted predictions of the model for particular class from least confident to most confident and tried tweaking one prediction until we got the response which satisfies the constraint. And actually it gave very similar results even for models which even when model 1 itself predicted a lot of constraint violating outputs. So it was kind of the same, but not much better, but not better, and it did not improve the training in any way. It just made sure that response is coherent with constraints. Next slide. Another peculiar thing we try to do is predicting entire valid combination, which at first seemed not like a very possible or good idea, but then we came up with possibility to split prediction on constraints group, because not all of the constraints, if you represent constraints as a graph, for most data sets, this graph will have multiple connected components, and we can actually have different model heads for each component. So it will only need to take into account possible combinations of constraint inside one head. So on the slide, you can see that for 8 data sets, we obtained more or less reasonable dimensionality of the final output, and we tried training on them. Next slide.
And the next method was like decision tree based method. It includes 2 models. The first model was introduced earlier, it's model 1. And the second model is the decision tree model. It accepts both input and output of the model 1, in addition to some combination, which you can see on the screen. For example, it's 0, 0, 0, 1, 1, 0, 1. That means that the first 3 classes are not present, the second 2 are present, etc. This model has shown to capture the constraints, even though we didn't explicitly mention them in the training. And that is kind of a good result, which can help in the safe model framework. So please, next slide.
Yeah, so one of the most promising results is give sequential conditional model, SCM. So we try to shift our perspective from each separate prediction to a whole combination prediction, and we want to have a distribution over valid combinations. So in LCMC problem can be very important because one class prediction can influence match on other class predictions. So we decided to create a model that will take a context, a previous class prediction from 1 to n-1, and will predict probability for class AN. So we also have the same model 1, we call it, as in all other approaches. And in this case, it's a simple GNN. And we have model 2. In this case, it's a sequential model that will take the context and will predict probabilities for a specific class based on this context. In our case, it also can be DNN. Also very important to know that actually this approach is model agnostic, so we can use any model H, like model 1, to generate the base predictions. So next slide. So the way we construct this model, we have the conditional probabilities, which we can then use to calculate the joint probability distribution over all combinations. So this process can be modeled as a tree. You can see that each level corresponds to a specific class, and probabilities on the edges is something that our model predicts. And on the leaf, we have all the combinations. So with calculating the conditional probabilities, we have distribution over all combinations, but then we have to ensure that all these combinations are coherent with the constraints. And then we do this check and just get rid of qualitative part that does not that's where like the constraints, and then we scale our distribution to, so again add up to 1, and then we have a distribution only on valid combinations. So next slide. So the most interesting part is our results. Here you can see 3 metrics and a lot of approaches, because we don't have a lot of time to cover all our approaches in this short presentation. So in general results, we have here CCN. That was a result of CCN that was presented in the paper, and our CCN reproduced results, because we included new metric called accuracy. Pure accuracy, the fraction of correct predictions, to evaluate our approach. And in general, we can see that there is no best model for each of data set and each of the metrics. For example, for the Jaccard score, CCN is the best, but for Hamming class, SC sequential model shows the least Hamming class. But so in general, this Jaccard score and Hamming class from model to model doesn't differ much. But if you take a look at the pure accuracy, we can see that there's pure superiority of SCM approach, sequential conditional model. So our model, by learning the distribution over well combination, can just do a great job of classification. And in our opinion, accuracy is one of the most important metric, because it shows a fraction of the correct predictions. Not the like Hamming loss only shows how close we are to correct prediction, but doesn't show like the fraction of like, exactly right predictions. So our future
time,
works.
so please wrap up.
Yeah, we are finishing future works, and
Yeah, so the last thing we have to say is that there is still kind of a lot of possible work to do. So we didn't try partial supervision. We didn't explore data sets much. We would probably need to validate on more data sets and metrics. Probably we would need to try generate data sets, not infer constraints from the data. Or taking our best model, we should explicitly integrate constraints, use hierarchy of the constraints to improve our best model. Yeah, so if any questions, if you have time for any questions.
I don't think we really have time, Tanya, right? We're quite over time. Yeah. But if there is time at the very end, we can take a question on this paper. So I wanted to pause for just a moment, because I know people are going to start leaving, and a couple of people left already. Let's turn on our video so that we can take a couple of screenshots of everybody here. So I'm going to stop sharing. Katerina, maybe you can do this, yeah? Okay, thank you. All right, so video's on, if you don't mind. Not required, but if you don't mind, it would be nice to have some.
I took one, I will take another one.
Yeah, so you may need to switch between the screens, right? But maybe tell us 1, 2, 3, so we smile.
Okay, so wait a second. I took another. Okay, so 1, 2, 3. Nice. Okay, and then I will take off the second. I will take one of the second screen. Give me. Okay, and yeah, 1, 2, 3.
Okay.
Awesome. Okay, thank you.
Thanks very much. So we will continue now. All right. The next project is REST-Q, balancing resources and performance in RESTful parameterized queries.
Hello, everyone. It was a pleasure for me to take part in such a great and interesting project. This time was very productive for our team, so I would like to start with my presentation. During this time, I worked with my mentors, Romain, Pierre, and Belkis, who are from French National Institute for Research in Digital Science and Technologies, PIRAL team, and of course me, Ostap, from Lviv National University. Next slide. Let's start with the motivation. The motivation behind the investigation stems from the critical challenge forced in developing scalable databases and web applications, balancing resource consumption while maintaining acceptable quality of service. This issue is particularly prominent in RESTful applications that rely on parameterized queries for secure and efficient database interaction. Despite advances in database optimization, integrating these systems into cloud-based applications often leads to inefficiencies, resulting in both economic and environmental consequences. Cloud platforms, with their perceived abundance of resource at low cost, can exacerbate their inefficiencies through overallocation and missed energy achieving opportunities. Achieving energy efficient research usage is complex, as simple optimization or scaling strategies overlook the intricate interactions between database performance, application logic, and server infrastructure. Next slide. Moreover, existing tools often focus on either performance or energy efficiency, rarely addressing the trade-offs between the two. Many studies have examined individual components like database optimization or server performance, but they fail to capture the full picture, the interdependence of these systems, and their collective impact on energy consumption. This lack of integrated perspective creates a critical gap in developing energy efficient and sustainable RESTful applications. Our project aims to fill this gap and make a comprehensive study on the communication layer between database and server and their energy consumption in cloud-based platforms. Next slide, please. To address these challenges, we introduced the RESTcube benchmark that implements TPCH benchmark business logic. Using Spring and Hibernate, we developed a web application that mirrors real-world usage by retrieving data from a database through APIs. To replicate a cloud-like environment, we used Grid 5000, a French distributed computing platform that allowed us to execute performance and energy consumption tests across multiple nodes. This setup enables us to evaluate resource usage in a realistic environment. Next slide, please. As mentioned previously, we relied on Grid 5000 infrastructure. So to conduct experiments, we used 3 different nodes that communicated between each other. The first node is a database node. On this node, we store the information for the web application. The next one is node with deployed web application that allows communications through API for user and use JDBC to retrieve data from the DB. And last one is client node. With this node, we simulated client or clients making a request to our web application. As for each experiment setup, connection to the nodes and modifying their settings are required. We created automated running of the experiments using Ansible, which means to run the next experiment, you just need to change experiment values and not worry about deployment or compilation. Next slide, please. One of the most important processes in our benchmarking is energy consumption measurement. We use a tool called Scaphander that enables the tracking of energy consumption at the process level, providing detailed insights into the energy usage of various components in a distributed system. On the database server, Scaphander tracks the energy consumed by the database processes by handling queries and managing data. And on the API server node, Scaphander measures the energy usage of the process responsible for handling client requests and interacting with database. Next slide, please. After conducting our experiments, the resulting raw data requires thorough interpretation. To facilitate this process, we develop auxiliary tools designed to graphically visualize the collected data. These visualizations not only enhance the clarity of the results, but also makes the research process more intuitive and accessible. Next slide, please. The development and deployment of the RESTcube benchmark enabled the investigation of some research questions in RESTful applications. As the example, we were able to investigate question on how energy consumption changes with the number of queries per second. During our experiments, we followed the rigorous methodology using the same query consistently across all tests. Each benchmark was executed 10 times per configuration, repeated over 3 runs. This average energy consumption was then calculated to ensure accuracy and minimize outliers. And the following trends were observed: that the energy consumption of the API server scales directly with the request rate until the database server's query processing capacity becomes a bottleneck. Beyond these points, the additional energy consumption arises mainly from queuing operations, as the API server handles an increasing number of pending requests. Next slide, please. To sum up, the project resulted in valuable learning outcomes, including a deeper understanding of energy efficiency in web applications, database internals, and techniques for measuring energy consumption. And in terms of contributions, we developed the REST-Q benchmark for evaluating energy key questions and made initial contributions toward addressing them. And of course, we have a solid baseline for future research to build upon. And the next slide, please. Finally, the REST-Q project has established a strong foundation for accessing resource usage and energy consumption in RESTful application. However, key questions remain to be answered, offering exciting opportunities for further research and development. In the second term, we plan to enhance the benchmark, aiming to transform it into a valuable open source tool. And additionally, we will compile our findings into a publication to share insights on energy efficiency in RESTful application, in RESTful systems. Yeah, so thank you for your attention, and now it's time for questions.
Thank you very much. Very interesting work.
I
Questions?
have one question. Have you created a custom generator for your system so that to test your system in the whole, right? Or is it custom generator? Or did you use existing ones?
Yeah, for generation of what do you mean? The data or the load of the database?
Yeah, load.
Load
You
for load.
try to generate queries, yeah.
Yeah. For load, we created our own benchmark system. So yeah, so it's our library, framework.
Yeah. It's just maybe a suggestion. I just posted in the chat tool, which is called Gatling. It's probably the most popular tool which is used in industry to generate queries for your system. So actually, this tool is used to, it's quite big tool. You can create scenarios there, and it can generate you can set, I want 1,000 queries per second. So, and it already can do that automatically. So this tool is very robust. It's used in industry, so you can maybe use in your research instead of creating custom things.
Okay, thank you for suggestion. We'll take into consideration.
Yeah, and also it creates graphics. So if you have actually questions about it, I used it. I stress tested my system some time ago to do that. So it creates loads visualizations. So maybe you can try to reduce also. Yeah.
Okay.
Oleg and then Victoria.
First of all, thank you for the presentation. So my question is, in the industry, it's a common practice to do horizontal scaling when the load on your server reaches some parameters or when CPU starts taking, some amount of load. So based on your presentation, do I understand it correctly that from the energy efficiency point of view, horizontal scaling is always bad?
No, by our findings, we cannot be sure that it is true. We identify this as our research question, but we actually haven't tested it on different sets of data. So we need to test again, to be sure if that's correct or not. Yeah, so for now.
Could you skip back a couple slides up until the graph of energy efficiency to the database load? Yeah, so I'm asking mostly due to this graph because based on it, with increase in number of queries, after some point, the consumption barely scales. So yeah, thank you.
Victoria.
Thank you. It's very interesting research. I had a question, like when you did research, did you have a difference in complexity of queries that you used, or you just used some simple type of queries and your goal was to analyze queries per, I don't know, per second maybe?
Yeah, so basically we implemented the PCH benchmark, which means, and this benchmark offers a range of queries with different a level of complexity. But as we needed to get more results until our presentation and so on, we focused only on just one query to be sure that our data are correct and there are no any outliers in our data. But for future research, yes, of course, we will investigate this question.
Yeah, and it's also very interesting how different types of optimization may influence this energy consumption. Thank you for your research. It's very nice.
Thank you.
Very nice. Thanks very much. Let's move to the next presentation on fair and explainable multimodal AI for automatic knee osteoarthritis diagnosis from X-ray and MRI and metadata.
Yeah, and then hello everyone, and go to the next slide. Go to the next. Yes, thank you. So knee osteoarthritis is a major health issue and causing pain, and disability, and current diagnostic methods such as X-ray, MRI are subjective and often inconsistent and leading to challenges in therapy assessment. Also, AI models have shown promise in medical imaging, but they typically focus on the imaging data, ignoring important clinical metadata like ancient sites that are crucial. And many AI lack transparency and fairness, and that yeah, and that fact it make it difficult for clinicians to trust and to model the practice. And go next. And yes, and about research, yeah, about our objectives to address these challenges. And research focuses on three objectives. First is develop multimodal AI model that integrate MRI imaging with clinical metadata to improve diagnostic precision. Second is enhance transparency by incorporating scalability features, making the AI decision-making process clear and straightforward. And third is achieve accurate and advanced predictions by designing models to reduce biases and improve fairness. And go to next. And from a technical point, we aim to mitigate biases using diverse data sets to create models that combine imaging with metadata for more robust analysis. And expandable AI features will build trust, helping clinicians adopt this model with confidence. And clinically, we will support clinicians with AI tools and standardized diagnosis minimum variability and proven efficacy. And to next.
So about the data, we use data set actually from NIH OAI. This is an initiative which collects a lot of a large amount of medical images and data, including X-ray and MRI images. So yeah, they contain a lot of data, but we used only approximately 7K samples because of our computational limitations. So each sample contained nearly 35 images per each sample. Also, each of them contained clinical data, and it included such features as sex and race. And our outcome or target variable was a binary variable, which was modified Kellgren-Lorentz scale, like two cases, one for which is less than 2, and second one equal or bigger than 2. We divided all our data into 3 parts train validation test, 70, 15, and 15% respectively. Next slide, please. So here you can see the distribution of data using some of the features. So they are more or less evenly distributed if you do not talk about race feature, because here we can see clearly like small problem because like you can see that two classes are not very balanced well, but because we did not have much data to train, we decided to proceed with this and to see what result we get from this data. So let's move to the next slide, please. Yeah, here you can see the general architecture of our approach. So like at the heart is a 3-dimensional ResNet, which works with this MRI imagery. Basically, at the end, to the last convolution layer, we used such a thing as GradCam++, which actually helps with visual explainability. As you can see, it will highlight in red regions the most important regions of the image, which can explain the model's decision. And apart of them, we also use small MLP, which incorporated clinical data into our model. And in the end, we get 2 numbers for each of the class. So please move to the next slide. And so we experimented with a couple of variations of ResNet 18, 34, and 10. Each of them was in multimodal and monomodal variants. We used for training Adam's weight decay as an optimizer and cosine annealing as a scheduler. Yeah, please move to the next slide, please. And you can observe an example of learning graphs we got. I believe this is from ResNet 18 with MLP. So you can see that we trained upon overfitting on trained data. And we achieved nearly 0.8 accuracy and F1 score. Please move to the next slide. Speaking about results, you can observe that for each setup, it's true that it is really near 0.82 accuracy and F1 score, but you can see clearly the difference between various setups. And you can observe in the next slides why that there is trade-off between accuracy and fairness, and Yaroslav will explain it a little more. Please to the next slide. And this is just 2 examples of how GradCam++ outputs the results. So you can see that attentional maps, and these red regions are regions between 2 bones, their junction, and these regions basically tell us whether it is osteoarthritis and how severe it is. So I think Yaroslav will proceed.
Next slide. Yes, and now we are moving to the fairness comparison of our models. To compare them, we use skewed error ratio metric, which measures the ratio of highest and lowest error rates across demographic groups. In these tables, you can see a comparison between sex groups and race groups for each ResNets. And also you can see here that almost for every model, ResNet with MLP, which is multimodal and incorporating tabular data, gives better SER value. Next slide. Oh, you skipped something. Yes, here is visualization from which we can see that mostly for every cases multimodal models give more fair results. Next slide. Yes, and our conclusions are that while monomodal approach achieves slightly higher accuracy compared to multimodal approach demonstrates better fairness. And so multimodality has proven to be an effective approach for achieving more equitable performance across different groups. Next slide. For our future work, we planning to improve overall accuracy by exploring other deep learning architectures as we think we got to the limit of the ResNet, and also try other fusing strategies to incorporate multimodal data in other ways. We plan to finalize our research findings and also try to incorporate other demographic factors such as age, for example. And final slide, as deliverables, we plan to submit a paper to IEEE 2025 conference. Also, all our codes will be available, and also our mentors invited us to participate in HexAI podcast to further discuss our research finding.
That's good.
Next slide.
Progress in a short period of time. How are we on time, Tanya? Do we have time for a question?
One small.
Okay. If there are no questions, we can also move on. Thanks again. The next project is custom LLM, customizable LLMs for laboratory scale AI settings.
Yes, hello everybody, my name is Alexander and I'm one of the research fellows for this project. Also, Radomir is a researcher, and we were doing this project under the mentorship of Bill, Bin, and Robert. Next slide, please. So, object of this research was reasoning with smaller models, and OpenAI are doing quite well with test time compute. And we see that iterative thinking is way better than some quite popular techniques like mode training, single pass prompt, context, and few shots. So the questions we want to consider are how hard are these reasoning tasks for small models, how close can we get using conventional approaches and guidance, and what makes reasoning so hard. Next slide, please. Here you can see, yeah, thank you. Here you can see OpenAI results. So on this slide, we see that O1 series models, they do way better than GPT-4o, so previous models. And here you can see that they even tested this on datasets we have chosen next. So AIM 2024 and GPK Diamond. Next slide, please. And also we have fresh results from Hugging Face from the December 16th this year. So they achieved the same results, having like 8 billion model parameter versus 70 billion model parameters. And they have this like idea that is described here. So they generate intermediate steps and verify estimates P and search strategy to select steps to expand until conversion. So this shows that this problem is quite important, and still there is some place to explore. Next slide, please. Yeah, so we have chosen, some text disappeared, okay. So we have chosen Llama's 3.18 billion model from Meta because it's smaller, it can be easier to use, it can be easier to implement, and it can be like, it's one of the best small models you can use. Next slide, please. And datasets. So we have chosen two datasets, AIME 2024. It's an extensive and carefully curated collection of mathematical questions, and GPK Diamond, graduate level Google Proof Q&A benchmark dataset that contains questions written by domain experts in biology, physics, and chemistry. So we have chosen these datasets because OpenAI have tried to estimate their model on these, and these have like quite difficult questions in various scientific domains. So I guess that's a reasonable choice. Next slide, please. And about subsets. So in order to test various techniques, we created subsets from with 15 questions from each dataset. From the AIME dataset, it's only math, so it has like 15 math questions. And as GPK Diamond has various subdomains, here you can see the question distribution in a test subset. So we have like 5 from quantum mechanics, 4 from organic chemistry, 2 from physics, molecular biology, and so on. Next slide, please.
Okay, so here's one example of AIME dataset. We can see that the question is somewhat related to maths, and it requires a lot of reasoning. And in the bottom part, we can see O1's previous reasoning. It first provides some steps it will do, and then it provides like 100 lines of actually solving these steps. Next. So at first, we tried a few basic techniques to test whether small models can improve with just like few shot or fine tuning. Few shot is given a few examples of solving hard questions before given the actual question, and fine tuning is further training. In our case, it was 100 questions from previous years of AIME dataset. Next. And we got the result that small models even with these techniques could not produce any good results and had 0% score. So next. Our next steps were trying to guide the model into doing harder problems that it could actually do. So to accomplish this, we tried the next few approaches. The first one was just generating the solution outline using one preview, and then providing the smaller model with the outline and asking it to solve the problem. Then there was read answer. It was just given the whole solution made by O1 Preview and asking the model to just find the right correct answer in that solution. It was an easy task, but needed just to know whether the model can follow the thinking. And the final step approach was providing the smaller model with the whole solution, except for the last step. Next. So our prompting looked like this. We gave a system prompt explaining the smaller model what to do, and then a user asked the question and gave the outline of the solution. Then we asked the model to solve the whole problem. Interestingly, while the small model can find the answer in the solution and does not get lost completely, asking it to just complete the last step did not yield significant results. Next slide. Yeah, so it did not have more score with the whole solution except final step than with just hints. Next slide. Therefore, we tried evaluating it step by step. Next slide. So we asked it to do the first step, asked O1 Preview whether it did the first step correctly, and then provided it with the correct first step and asked to do the next step. Next slide. And our result was that even though it did only 13% of questions correctly, 55% of them, of the steps were correct.
Participants require is larger than our time constraints allows.
Okay, so the next slide, please. So our conclusion is that the model might be capable of doing the harder questions, even though its score might not be as well. And the last slide. So the future work includes characterizing these steps as harder or easier to do and experimenting with more test-time compute strategies.
Right. Thank you very much. We have time for questions, do we?
1 minute maximum.
Let's do it. Any questions? What did you enjoy about this project and what was difficult?
Working as a team is difficult.
I guess working with the team and finding new ways to get better results, because you usually like trying to explore and create something new, and it's always quite hard thing.
All right. Okay, thank you. Let's move to the next project, which is on designing reminiscence therapy chatbot with culturally sensitive visual stimulation for mental health.
Yeah, hello everybody. So our team worked during this semester on this project. Our mentors are Jinyuan Hong and Joan Fan, and our research fellow team is Sia, Katerina, me, Julia, and Ostap. Next slide, please. First of all, let's talk about reminiscence therapy. It is a therapeutic approach that encourages individuals, people with dementia, to recall past experiences. Using prompts like photos, music, and familiar objects, it aims to boost mood, improve memory, reduce anxiety, and foster social connection. This therapy is often done to stimulate positive emotions and maintain cognitive function. Next slide, please. In the scope of the project, we want to implement Remy chatbot, which includes both conversational and visual parts of the therapy. We also want to explore what the impact of 3D visualization is. So we set the following goals. First, to implement Remy chatbot, and second, to test the effect of 3D visualization. Next slide, please. So reminiscence therapy consists of specific sessions. In our case, Remy chatbot is facilitator of the therapy. It has to guide the conversation. So our initial task was to develop the appropriate prompt for the chatbot. So here you can see the structure of the prompt, which corresponds to the session structure. The first steps are the beginning of the conversation. The chatbot finds how the user feels at the moment, and then they talk about his specific memory in detail. At the end, the chatbot can rate an image and a video of the place from this memory. Next slide, please.
And now let's talk about how we developed the application for Remy chatbot. Remy is a website where the user can just click one button and have a therapeutic conversation about his past positive memories as with his friend. The base for our application is the OpenAI real-time console, and the main part of it is a relay server, which contains all the backend part, including tools for audio recording and playback, voice activity detection tools, and more, which you can see on this slide. The chatbot collects the memories the user tells it during the whole session, for example, the description of the place, lights, colors, sounds, atmosphere, people, etc., and stores this information in a JSON format. At the end of the session, it initializes the function that generates a memory reconstruction from these memory parts. Next slide, please. Now, a few words about the front-end part. Our focus was on simplicity and calming effect during the session. So here you can see the user interface of the Remy chatbot, and later you will see how it works. Next slide, please.
Traditional 3D reconstruction methods needs many photos from different angles to reconstruct a scene, but memories often come with just one photo or even a text description. ViewCrafter works differently. It's a 3D reconstruction method that uses diffusion models to generate 3D representation and videos even from one image. Diffusion models work by gradually adding noise to images and then learning how to reverse it, filling in missing details step by step to produce realistic results. This is shown in this illustration with the dog. Next slide, please. Firstly, we tried creating 3D models using PLY files. It's a file format for storing 3D point cloud from ViewCrafter and visualizing them as splat. It's like rendered points or mesh, polygon-based surface. We wrote programs to display this data, aiming to create interactive 3D scenes that could be explored from different perspectives. But the PLY file from ViewCrafter were missing key details like rotation and scale, leading to distorted visuals. We tried improving the results with triangulation on the point cloud, but it still produced artifacts and low-quality meshes. Because both methods failed, we shifted focus to video generation instead. We started by generating images. Initially, DALL-E 2 didn't deliver good results, so we switched to DALL-E 3 for better images. After that, we used ViewCrafter to turn images into videos. When the default ViewCrafter API failed, we deployed its custom own Hugging Face space, modifying its code for smooth integration. And this approach worked efficiently. On the next slide, we'll present a short demo of our chatbot's work, highlighting the case steps and results. Sorry, next slide. Yeah, can you play the video?
Hello, it's lovely to meet you.
Can you see it?
Yeah.
Yes. Now it's
My name is
perfect.
Remy, and I'll be here to explore some wonderful memories with you. What should I call you?
I'm Kate. Nice to meet you.
How are you feeling today?
I don't really know.
That's okay. It can be hard to pinpoint our feelings sometimes. Would you like to take a look at an emotion wheel to help you describe how you're feeling? Okay, I've shown you an emotion wheel. Let me know which emotions stand out to you. What's a moment from that time that stands out to you? It could be a special event, a close friendship, or a personal achievement.
I think it's time when I walked near the Lviv Opera House with my dear friends.
What can you tell me about the atmosphere? Was it a sunny day or perhaps an evening stroll?
As I remember, it was autumn, a rainy day.
We can also visualize this memory together if you'd like.
Let's try it.
Please wait while I generate a visualization of your memory. Now creating a short video animation from this image.
And now next slide, please.
Hello. Hello, it's lovely to meet you.
And now I will sum up. So,
do you see the screen or not?
Yes.
Okay.
And now let's quickly talk about the survey part. Survey is a very important part in such kind of projects that we have. So we carefully planned it to test our chatbot. The main goal was to evaluate whether and in what measure the visual memory reconstruction improves the effect of the reminiscence therapy and understand how the cultural and personal relevance of this reconstruction can affect user impressions of the therapy. But unfortunately, the number of participants we require is larger than our time constraints allowed us. So it was decided to continue our survey in the next semester and demonstrate its results in our future research paper. Next slide, please. So our future goals are the following: to fully conduct the survey with 20 plus participants for quantitative statistical feedback, introduce a research paper, and additionally to improve our memory visualization and build interactive 3D visual reconstructions as the next step. Finally, we also would like to deploy the REMI website. That's all. Thank you so much for attention, and we would be very happy to answer your questions.
Do we have time?
No.
There are 4 projects, I think, to go,
Yeah.
right? So let's just continue. Thank you. This is very interesting. And the next project is Model Explain. Please.
Hi everyone, my name is Irena. My team that consists of Bogdan Turpel, Mykola Vysotsky, our mentor Lesya Semenova, and I have been working on a project called Model Explain, and here's our final presentation. Next, please. So imagine you're going to a bank to ask for a loan. The bank you're going to uses machine learning to make a decision, and your question and data is sent to a model. Next, please. So you get rejected. A natural question is why? As the model the bank uses is black box, meaning we don't know how it works, they ask an explanation method to help them out. Next, please. For example, Lime says that your income is too low and it impacts negatively on the decision whether to give you a loan. Next, please. So you increase your income significantly. You go to the same bank and ask for a loan again. And next, please. But get rejected again. Like what? Next. The problem is that the bank uses post hoc explanation method that is actually not always faithful. Next, please. What has actually happened is that your bank works under Rashomon effect. It means that there are many good different models. The set of all good models is called Rashomon set. There actually can be thousands of such models, but only one is usually deployed. The assumption is that the existence of a large Rashomon set leads to model agnostic explanation methods providing unfaithful explanations. Who knows how did the model actually make the decision to not give you a loan? It could be even because you're a woman. Next, please.
As the goal of research is to really formally understand, is it really true that existence of Rashomon set leads to high unfaithfulness of explanations? And of course, it would be very nice to understand why might this happen. Next. Recently, there appeared a lot of methods that allow us to enumerate whole hypothesis space of sparse decision trees. This give us unprecedented opportunity to look at each tree in the whole Rashomon set and study some properties. Next. But what's really important is that the decision trees are interpretable. This means that we can extract ground truth paths, as this is a key difference from the example above when we explored how banking system works and so on. And this gives us opportunity to compare ground truth paths of decision trees to other explanation methods like SHAP, Lime, and counterfactuals. For this reason, we developed a set of specific metrics for evaluation of properties. I won't go into very much details, but you are welcome to ask about them afterwards. So equipped with these metrics, we found that. Next. First of all, general statements that Rashomon sets can be quite large. Depending on the hyperparameter, datasets, properties, the Rashomon set size could range from 65 trees to up to 3 billion trees. So it's very interesting. Next. The second observation is actually local explanations fail to explain a lot of cases. Like on the graph, you can see on x-axis, you can see methods and datasets, and on the y, percentage of unfaithfully explained. And for the landed dataset, you can see that like from 26 to 38% of cases, you just get wrong explanations. You're going to the bank and you just don't get the answers you want. Next. And even more importantly and interestingly is that if explanation doesn't explain concrete tree correctly, on average in 70 cases, it explains correctly at least one other tree in Rashomon set with the same explanations. What it means that under Rashomon effect, model multiplicity, sharp explanations actually could be kind of correct. They're just not explaining your tree, your specific model. They explaining similar model to yours that also contained in Rashomon set. And for the FICO, you can see that like in 80 to 83%, it explained at least one other tree from the Rashomon set, while not explaining concrete our tree. Next. So why could this happen? There is a lot of reasons. There are a lot of reasons, but one of the main hypotheses is that the leaves that are getting substituted have low entropy. For example, you can see the tree on the left, ground truth paths are marked by green arrows, and paths explained by sharp are marked by red, but it isn't explained correctly. But at the same time, exact explanations are right for another tree on the right from Rashomon set. But like, why is this happening? Next. And again, these leaves that got substituted have low entropy. So for sharp, for example, it have like low amount of information and marginal effect. And it got substituted to other with higher entropy leaf. Next.
Yeah, so now we are ready to answer our key questions. So first answer is for question, is it true that under Rashomon effect there is a high explainability and faithfulness? And the answer is yes. Next slide, please. So, and the second question, why this might be happening? And as we said before, so one hypothesis is that low entropy of some features on the decision path. Next slide, please. And briefly about our future steps. So we plan to continue further study the phenomenon why the phenomenon occurs, investigate if the robust explanations indicate the problem, and provide some specific instructions for data scientists to work under the large Rashomon sets. And next slide. Okay, so and thank you for your attention. And our report and GitHub is available with the QR codes.
I have a question. Sorry. So it's kind of right back at you, right? You asked us how is it possible that a sharp explanation is not faithful, right? So what do you mean that these explanations are incorrect? That's part one. Part two is, are you're finding specifically for trees?
Okay, so first question is that trees are interpretable. Like again, the main difference is the like advantage of using white box models like trees, not neural networks that quick like can get ground truth. Those sharp explanations aren't faithful to the ground truth. Sharp explanations compute like marginal effects of some features to the predictions, and they have some say like set of axioms like the sum of sharp values equals to prediction, but they doesn't guarantee a faithfulness to the original ground truth for specific example. And the second question.
Sorry, so you're given an explanation, you are unable to reconstruct the prediction. Is that what you're saying?
No, it means that the features that were used on the path are not the same as the feature that SHAP claims to be important.
But that's okay. I mean, that's actually by design. Right? Feature importance is not literally what feature is used to navigate the tree.
Yeah, but there is a lot of papers where like we have settings, black box model, and we trying to get explanation by using some other method like SHAP values. And again, in this part that it's by design is that because it's not faithful, because it just doesn't compute like ground truth. It computes different metrics, but at the same time, it often used. And because it's used, like it constitutes a problem.
Okay, we can take it offline, but I think that what you're finding is that how a model works is not necessarily what the model does. And this is actually by design entirely, right? Because if that wasn't the case, then we really wouldn't need SHAP at all, right? You could just use the internals of the model to explain what's going on. Okay, I don't want to dwell because we have one more project and we're we're out of time, but we should definitely follow up. Sorry, I have usurped the question. Let's go to the last one. Last but not least is urban AI.
Hello, my name is Ihor. I'm a machine learning engineer. I've been working on a project called OpenAI with my colleagues, Mariana Pies, software engineer, and Dmitry Stavanchuk, machine learning engineer, under faithful guidance of Professor Annette Caspi, Bill Howey, and Himanshu Naidu from the University of Washington. And we are unbelievably thankful for their mentorship and hard work on this project. Next slide, please. So what is the project about? You know that a lot of people have disabilities, and most of them really rely on the sidewalks to navigate the cities due to their limited mobility. So that is the case, and as you know, there are a few sidewalk maps available online that you can use to navigate, and it is really hard to label them manually. So the goal of this project is to automate this process using with a little bit of help of machine learning and computer vision. Basically, it's an iOS app that you can run on an iPhone or an iPad that uses your camera data and the LiDAR data and computer vision algorithms to compute the locations of the sidewalks or other objects that could be relatable to these sidewalk maps and could be used with people with disabilities. Next slide, please. We had a couple of goals in this project. One of them was to implement the database update as a part of a software engineering thing, complete the segmentation mass post-processing, and update the user interface. My colleague Mariana will now expand more on the database update.
Yeah, so to enable database updates with our points of interest, interaction with TDI workspaces was required. The first step was to handle authentication, and to achieve this, the following features were implemented. Login into our application for users with an account in TDI workspaces, and upon successful login, the server returns an access token, which is used for authenticating subsequent requests, and refresh token. Both tokens and their expiration dates are saved into the keychain. The application automatically sends a refresh token request to the server whenever the user is on the main screen, ensuring a seamless session without requiring relogin. And a logout feature was implemented to allow users to terminate their session. You can see all these features in action in the demo on this slide. So next slide, please. After implementing authentication, we are able to push data to the server, after which it is saved into the database. All requests sent to the server are authenticated using the token obtained during login. We push geospatial data to the server in a format compatible with OpenStreetMap standards, and the workflow is the following. First of all, opening a change set. It ensures that all updates are grouped logically and committed as a single unit. Then geospatial data, latitude and longitude, and tags are formatted as nodes in the OSM structure and uploaded to the server. And finally, once all changes are uploaded, the application closes the change set, which ensures that the data appears on the Workspaces API. And on this slide, you can see the data previously uploaded by us using described workflow and observed using Postman. Next slide, please. So let's talk about user interface update we did. So in order to give users possibility to provide us feedback on model assigning classes, we worked on improving annotation view. Previously, users could only validate the class assigned to their point of interest by selecting one of the following options. I agree with this class annotation. Annotation is missing some instances of the class, and the class annotation is misidentified. But now, when users select the last option, a new sheet opens, allowing them to
to assign the correct class. So users can choose the correct class from the list of classes they selected at the start of the session. So that's it. Please move to the next slide.
Okay, after segmentation model works, we want to identify points of interest. For linear features such as sidewalks, also this is depend on which segmentation model is used. We will identify the center of lines as well as width. To reduce noise in segmentation masks, we use the union of masks. After finding point of interest, the coordinates of the found points are calculated based on the distance to the object, the device rotation angle, and device location data. So the next slide, please.
We have also implemented some segmentation model improvements. Before this project, they have used DSP.NET v2. We have implemented a version with DeepLab v3, which is kind of near state-of-art segmentation model that can do actually and object segmentation and probably do depth estimation as well. It could use different models under the backbone from ImageNet trained, let's say ResNets, to Cityscapes trained MobileNets, which is kind of cool because we can plug and play with different models and datasets and see the results. However, we a bit underestimated the CPU load of this model, so it still needs to be worked out how to make it run on all of the iPhone models, because some mobile devices are not actually capable to do this in real time. Next slide, please.
In future, currently the application supports individual nodes. To support a wide range of classes like roads, sidewalks, we plan to focus on supporting ways. This will align more closely with OpenStreetMap standards. Sometimes model fails to detect certain objects, which creates a gap in the application functionality. For that purpose, it would be great to integrate a canvas tool on the annotation screen that allows users to manually draw and annotate points of interest. And we want to extend our pipeline, so working with point of interest. So.
All right, thank you very much. Do we have time for one question and then we go?
1 minute.
1 minute. It's 1 minute to the end. So let's, if there's a burning question, please ask about this presentation. If not, I'd like to wish everybody a happy new year and be safe, be well. Thank you for your hard work. These results are absolutely amazing. And we will be looking at your reports and we will be in touch with your mentors to then suggest whether we would like to continue working with you. So once again, thank you. And I hope that this was a nice experience for everyone.